I don't know, has anybody ever had a teacher that you think told you that?
Yeah.
You need to write them or go track them down. Slap them. No, don't. But I'm almost serious. I mean, because that is major bullshit. That is foundational cracks. And then I'm trying to get you to build a house on top of this. You know, I don't know if you get the analogy I'm making. If your teacher's telling you wrong before you move to the next level, how can I build on that? They've told you wrong, and I'm kind of angry at that. I am, and I'm not coming at you with this. I'm upset at the person that was before me that taught you incorrectly. If you think about it, do you understand what I mean by these are the same thing? There is no division, right? There is no division. Because division is multiplication by the reciprocal. They're the same thing. So watch this. Well, real quick, let me just write this piece of it by itself. Maybe there's that piece. How would you rewrite that in a different form? What's the other way I can represent division? Or 16 over 4, right? 16 divided by 4 is 16 over 4. So let me just bring everything back in. 4 minus times 2. So wouldn't this be 4 minus times 2? Wouldn't that be the same thing? What's the only thing on the bottom? What's the only thing underneath something? 4. Not 8. If you did this first, wouldn't you suddenly have an 8 underneath? How the hell did that 2 get down there? The 4 is the only thing dividing. So even if you rewrite it in this form, it makes more sense as to why you do as it comes. You don't make this 8. That's not fair. How did that 2 get down? Poor little 16's being cut in 8s? No. It's only supposed to be cut in 4ths.
So do you do it from left to right?
Totally. Yes. I like it. As you read, I like it. All right, let's do a few more because this is troubling. Okay. And again, I'm not coming down on you guys, but if you don't get order operations, you're screwed. Because it's always going to be parts of problems. It's always there, yeah.
Can we do the equation from the quiz, or is it too soon? I just got really confused.
So real quick, there were like 4 versions of this quiz out there. So I'm not going to do... Alright, there's like 4 different versions, so I'll do a problem like it. We'll do a few. I'll do one just like the one on the quiz, and then we'll do some other ones and some mixtures of stuff going on. Because this is huge. Order operations is the grammar of math. If you're taking a foreign language and you don't get the grammar, why the hell would you go into conversation class? You're screwed. Me go house, yes, white. Go back a level. Alright. Me go house, yes, white? Yes. So the one on the quiz looked like this. So I'll make one like it. Yeah, I can do that. So that looked vaguely familiar, and everybody had one that looked something like that. Alright, so here's how you do this. The less comfortable you are with order operations, the more you just do one thing at a time. So what's the first part of order operations? Parentheses. I like it. So are there parentheses? Yes. And that parentheses really means inside the parentheses. Is there something you can do inside the parentheses? Of course. And what can you do? What is 2 minus 4? Okay, so how can I cube it until I know what the hell it is? Think about it like that. How can I subtract this from 7 until I know what the hell this is, right? So 7 minus negative 2 cubed divided by 2 times that plus 1. Everything else just stays there. And the more comfortable you are, the more you can do several things at once. You just got to show me something. Now what? Exponents is next. Yeah, I've done everything inside the parentheses that I can. What is negative 2 cubed? Negative 8. 2 negatives cancel, leaving you with 1. I'm so happy I didn't flip you guys off. So then negative 2 is 4 times another negative 2 is negative 8. Do you see how I replace that with what it is? I replace that with what it is. Everything else stays exactly where it is. And I should have said this at the beginning, but what do I definitely do last here? It's a lot like the one we just did. What do I do last here for sure? Subtraction and addition. So that 7 is just going to keep coming down, and that 5 is just going to keep coming down, because you're just waiting. You're like, come on, middle dude. All right, man, don't you? Leave me alone, Rick. Come on, middle guy. So what's, there's a couple different ways you can look at this. Minus and negative is plus. What do I do first? So is that cool if I just do that? Is that all right? What do I do in here? Because I know I do these last, right? So what do I do in here? Yeah, just because, not always, but just because division happens to be first. So don't try to make M or D first always. It's just whoever got there first. Division got there first, you go 8 divided by 2. 4. Then I put the times 7 plus 5. Can I do my addition yet? No. Why? There's still multiplication. I'm still at this level. I can't go to that level yet. So what's 7 plus? So that's there, right? 4 times 7, 28. Now I can finally do everything. 7 plus 28. 35 plus 5? 40. 40. Cool. I like it, I like it, I like it. Yes?
How would you make it positive?
So right here, there's a couple different ways to do this step. That's the easiest way to do this step, is anytime I have a negative times a negative, it is a positive.
Okay.
So it becomes plus instead of minus.
Yeah, because it's technically a 1.
Yes. Or I could have done this. Everybody has that written down if you wanted it. I could have done this. What is negative 8 divided by 2? Negative 4. What's negative 4 times 7? Negative. Now I can finally say minus and negative. So I'm just like, do it first. So you don't make it leave a negative out or something, right? Okay. Does that make more sense? Yes, sir.
So, like, if you have a problem and you do everything and then you get to the addition and subtraction, if the subtraction is first, do you do that? Or
Totally.
Okay.
Let me show you an example. I always make this joke about if I got $4, I got $4, and I owe you 10. But then I find a $20 bill. Can I pay you off? If I got $4 and I owe you 10 before I found that $20 bill, could I pay you off?
No.
I got $4, I owe you 10. Shit, but then I find a $20 bill. And then if people look at this and they say, oh, addition first, 4 minus 30. Now I owe you $26? That doesn't make any damn sense, does it? I'm like, don't do my checkbook. Shit. So you do it as it comes. 4 minus 10. Negative 6. That makes sense, because if I owe you 4, I'm sorry, I have 4 and I owe you 10, I can pay you off to the point where I still owe you 6. I mean, that makes physical sense. I find that $20 bill, I'm like, oh, thank God, don't break my thumbs. I pay you off, and how much money do I have left over?
14.
Ooh, I can get a good lunch. Right? I don't have to go to Taco Bell and hate life later. Yeah. Alright. I get 2 pizza slices here. That's expensive here, actually. Alright, let's do one more. Which is fine, because we actually got some time here, because this was sort of my day to catch up with any questions you guys had, and this I am not going to leave in the dust, because it's stupid important. So here, what about this here? Oh, let's see what we got, Jeff. Okay, that'll work. Yeah. The people that are lucky and they get through math easily and that you sit there and you secretly hate are the people that just sort of naturally break things up. That's nice for them. They're just sort of hardwired to do that in a way. When I look at this problem, I realize that I just got to worry about 2 squared. Right now, that's all I got to worry about. Does somebody see what I mean? Because what's the very first thing? What do I look for? Parentheses, right? Is there anything to do inside there? No, so he's not really parentheses. Is there anything to do inside there?
Yes.
And inside here, what would I do first?
2 squared.
You see, so everything else doesn't mean shit to me right now. I just rewrite it, and some of you guys are moaning because you're like, I gotta write all that crap. But you know, I understand that to a point. I'm tired already. Sorry. 7 minus 4 squared. Everything else is exactly where it is, and the people that try to are going to be putting 15 there. That's crazy. Why is putting 15 there crazy? Because division is first, and it's before this multiplication, right? Actually, this multiplication is first in there, right? Okay. All right. So what do I do next? Am I done inside here? So what's 7 minus 4? 3. That's crazy. So now I got a couple of exponents to do, right? So now I'm done with my parenthesis level. I move to the next level. So again, some of you guys are like, man, why are you showing every single step? Because I want to show people if you're not comfortable, you should do one thing at a time. One thing at a time. So then, what do you get here? So 5 minus 2. What do I put here? Yeah, that's times. It better still be times. Divided by 3 times 5 minus, and what's negative 2 squared? 4. I don't really need those parentheses, but I just put them there. Just be careful. Now what level am I at? What level am I at? MD. Doctor. Yeah, so what am I going to do last? That's subtraction. So this chunk in the middle is an MD chunk. So I'm going to do it as it comes. So what do I do first in there? 18. 2 times 9? 18. What do I do next in there? Yeah, what's 18 divided by 3? 6. And see, I just keep rewriting. I did that there. I did that there. Everything else is exactly the same, because all I'm doing is anywhere in the universe I see 2 times 9, I could put an 18 there. I don't care what else shit is around it. I know 2 times 9 is 18. And then everything else around it just kind of stays there. Now, what do I get? Alright, so that's 5 minus 30 minus 4. What's 5 minus 30? Negative 25. Minus another 4? Negative 29. Cool. Alright. Yes?
Yeah, I haven't taken that in a long time. So the ones that mess me up are fractions.
Okay.
All the fractions. Like adding fractions, multiplying fractions.
Wait.
It was like a fraction and
Just fraction plus a fraction, right?
Yeah.
Okay.
Since it's a negative, it's minus.
So let's start off nice.
So
Uh,
yeah. I got 20 right.
This is like 5x plus 1y. I don't know if you guys see why. It's like 5 of these plus 1 of those. I can't put those together. They're not like terms. I need 5, 6 plus something 6. And I can tell you how many 6 I've got. That's the idea. So that's why I have to get, what do we call it? LCD, common denominator. Common denominator. So this was, I give you nice numbers. You should be able to tell what I do. I don't make them 12. Don't go crazy. I don't have to change both of them. I just can change this guy to 6. So I multiply by 3 over 3. So you get 5, 6 plus 3, 6 is 8, 6. You give me that number, depending on what's going on, I might take something off. Because that ain't quite right. What can I do with that? at least one thing. Reduce. Yeah, you can divide both by 2, so 4 over 3. Is that cool? If I get $8 for every 6 hours I work, number one, I got to get out of that job. If I get $8 for every 6 hours, I get $4 for every 3 hours. I mean, that's all reducing fraction means, right? Now that's fine. Or you can make it in mixed number. How would you make that a mixed number? 3 goes into 4 once with 1 left over. So if I don't say it, you can give it to me either way. I might say answer in mixed number form. I might say that just to make sure you can do that. If I don't, you can give me either way. All right, how are we doing so far? Is that cool? That's the basics. And then everything else is hard just because they're uglier numbers or something. And I gave you that way to look at this. So the problems I had on the quiz involved looking at it like this to make it easier. Like what, Jim? I don't know. What you got, buddy?
It was 35 and 25.
Too bad. I'm not going to do that one. I won't do anybody's specific problem because that won't be fair to the other 3 groups of people that have the other quizzes. That looks gross. What's the biggest number these have in common? How far apart are these? How far apart are these? The bottoms, how far apart are these?
They have 3 in common?
How far apart are these numbers? 6. Good. So 6 might go into both. Does 6 go into both?
Yeah.
Good. 6 is the biggest thing that goes into both. Do you guys see that? Maybe. So this is 6 times 6, and this is 6 times 7. So what's this guy missing that he's got? 7. So you give him a 7. What's he missing he's got? Another 6. Give him a 6. Now don't they both have the same thing? So what is 42 times 6 or 32? They're going to be the same number. What is it? 252. And what do I get on the top? What's this? 77 minus 6. So I get 71 over 252. I like it. That's a beautiful method. There's other methods you could use, but I love that method. I especially love this method because that's the method we have to use when we get to the point where there's like variables down here. Not just numbers. There's like x minus 1 and x squared minus 1 and shit. You have to look at it like this. So this is good practice for that, and it's a damn good way to do it for numbers even. How are we doing there? And the reason I can't put the original problem was this. And why do you think somebody was going to give me this answer here? Where the hell did that answer come from? That's their answer. Where'd they get that from? 11 minus 1 is 10. 11 minus 42 is negative 6. Leave me alone, Joe. But then I would say, well, that's crap. But then I would say, like, what's 3 halves minus 1 half? Are you going to get 2 over 0? That's bad. You just told me 3 halves minus 1 halves is somehow infinity. That's insane. Are you guys kind of with me? Okay. Have we talked about this? Did we talk about that? What is that? What is 2 divided by... that's obviously wrong, right? But 2 divided by 0, what do we call that? Undefined. Did I show you why that's true? I did. Let me just remind you guys. What is 10 divided by 2? 5. Why? Don't say because 2 goes into 10, 5. You use multiplication to explain why that's true.
2 times 5 equals 10.
I like it. I like the way you said it. That's very good. So 10 divided by 2 is 5 because 2 times 5 is 10. 5 is defined to be the number such that when you multiply it by 2, you get 10. Holy shit, Jeff, that's a lot of words to just say this stupid thing. The reason I say it like that is if I do 10 divided by 0, the answer has to be the number defined such that when you multiply it by 0, you get 10. So what number is that? What number do you multiply by 0 to get 10? Is there a number defined to do that? There's no number that, well, you multiply anything by 0, what do you get? So what's the number that I multiply by 0 to get 10? Ain't no such number. So there's no number defined to do it, so I call it undefined. Yes, ma'am.
In regards to the square root, there was one question that was like square root over 33, and is that the simplest term we leave it on?
So you're talking about on that worksheet that we haven't done yet?
Yeah.
All right, so we're getting there. Yeah, you're right. It's the same thing if I said factor 17, you'd say, done, because there's nothing you do. So same thing with that.
So you can't use the decimal version? I had a teacher say you could use,
How do you mean the decimal version?
like when you square root.
Oh, there will be some problems where I say use your calculator to find these square roots.
Yeah.
But that's simplification. If I said reduce this, reduce, what do you got, Jeff? Just make something up. Reduce that, and you say the answer is point something. No. Reduce this means simplify it, right? So if I said use a calculator to tell me what this is,
No, I'm talking about square root.
but no, so if I said simplify this,
Oh, okay.
we can simplify it. It would be square root of 9 times square root of 2, that's 3 square root of 2. We can do that. But square root of 33, can I simplify it? Can I break it up and simplify it? No. It's the same thing as if I said reduce this, reduce that. What would you do? There you go. There's nothing to do. So if I said simplify this, you circle it. Or you say can't be simplified more or whatever. Okay. Alright. Let's see. So let me just remind you guys about this. And I think we'll do that sheet. Have you guys, some of you guys apparently have tried this sheet, the sheet with the radicals on it. Does anybody need that sheet? Have you guys picked up on something about me? I live off of questions. Do you need one? Or what's up? Okay, hold on. Look at it. I need any questions. Hold on, stop. But what I'm trying to say is, the minute we go over something that doesn't make sense, ask questions. I'll do more examples, right? So this is beautiful. Part of me just wishes you would have asked these questions earlier. But at least these questions are being asked. And obviously, if you felt like you were the only one, you weren't, right? So anytime you feel like you're the only one with a question, you are not. Even though everybody around you is like this, they don't understand. I don't know why they're doing this. It's just, I don't know. They're like, teacher, I don't want you to realize until you see me fail tests that I don't have a clue. I don't understand that. So what's up?
With fractions, you're finding the common denominator when you're adding them.
Or
And
subtracting.
subtracting them.
I love it.
What about when you're multiplying?
I love it. So real quick, I'm going to write something that you're like, what the hell are you doing? I can add those, right? What do you get? 5x. Can I add these? No. If you tell me the answer is 5x cubed, I'll look at you funny and say, I don't see any freaking x cubes. How'd you get 5 of them? Right? Why can you not add these?
Because the 4x are not squared.
They're not like terms. I love it. Right? This has got x times x, and there's no other term that's got xx. Right? So there's nothing. If this was squared also, then it would be 5x squared. Let me make sure is everybody kind of with me, because this directly applies. But what's 4x times x squared? 4x to the third power, right? What do you do with powers when you multiply? You add them. So see how I can't do anything with this, but I can do something with this. So multiplication division is not as restrictive as addition subtraction. So when I'm adding subtracting fractions, if I wanted to do 1/4 plus 1/12, can I add them the way they are? No, because they're not like terms. So then I would multiply this one by 3. I get 3 plus 1 is 4 over 12, and then I can reduce it. All right, is that cool? But what about if I had 1/4 times 1/12? Can I do that? Hell yeah. Do I need LCD? No, it's multiplication. It's not as restrictive. It's not as demanding. I can multiply non-like terms, but I cannot add non-like terms. I like it. So 1/4 times 1/12 is 1 over 48. Does that make sense? I mean, that's LCD is the same as like terms. Why do I need them when I multiply or divide? Because I don't need it when I multiply or divide. I just don't. It's not as restrictive. I can still do something. But addition and subtraction requires like terms.
So no matter what the numbers are, you can multiply.
Yeah, no matter what the fractions are, you can multiply them. Now, of course, you want to reduce first if you can, but you can totally just multiply them, whatever the hell they are.
And then you can reduce it after.
And then you can reduce it after, but I would highly recommend reduce it first.
So the two numbers on top don't even have to be common. They could be like 3 times 6.
Of course. So, watch this. If I had 13 over 80 times 88 over 39. I just want to show you an example of what I mean. Dear God, please, don't do 13 times 88. It's not wrong, but you're being a little crazy. It's easier to reduce numbers when they're smaller. So what I mean by that is, before I even multiply stuff, is there anything that I can reduce? Hell yeah. 13 goes into 39 3 times. What goes into both of those? 8. 10. Now I can multiply. 11 over 30. Shabbat. Now if you did 13 times 88 and got that number, and then 80 times 39 and got that number, and then you have to reduce that shit, holy, that'll take you a while to get here, right? So please, your God, it's not wrong, it's just this is a better way. Yes?
Well, then when you're doing division, why you have to flip them over and
Did I show you guys why?
Why can't you just do the same?
You ready? You ready?
Yeah, I'm ready.
You ready? All right. All right. I guess I just showed, again, I'm teaching another class, we sort of do the same thing, so I'm like, didn't I do that already? Maybe it was 3/4 divided by, it doesn't matter, 4/5. Now there are freaky looking ways where you can just kind of divide across, it gets all freaky. I want to show you why what we do works, and then I think I'll let us go. How can I, now, please, you guys, understand this. I am not saying do it the way I'm about to do it. I'm about to show you why what we do works. Do not do what I'm about to do. You'll see why. What's another way to write something divided by something? Instead of a division symbol, I can use... So how do I write 16 divided by 3 in another form? Over 16 over 3. So how do I write this fraction divided by that fraction? This fraction over that fraction. Do you like that? No, me neither. So you're like, why did you do it then, Jeff? You're in control. Well, I want to show you. So how do we do this? I heard some of you guys, you multiply by the reciprocal, but your question right now is, why the hell we do that shit? Beautiful question. You didn't use the word shit, but I knew you wanted to. So watch this, watch this. Stay with me. This is why it works. Don't do this. But why does this suck? Because there's a 4/5 on the bottom. What's the best number to have on the bottom of something? You can do it? 1. Shit, yeah? So how do I make this become 1? But can I add the same thing to the top? What's the only thing I'm allowed to do to the top and bottom of a fraction? Multiply or divide. Alright, so what do I multiply this by to make it become 1? 5. Do you see how the 5s are canceled? Over 4. So I multiplied by its reciprocal, right? Interesting. And what did I just do to the bottom? I multiplied it by 5/4. So what do I better do to the top? I better multiply it by 5/4. Stay with me now. So that means this equals this, which equals over 1. So screw that, right? I don't have to write over 1. So that equals this. This is the reason why I'm allowed to multiply by the reciprocal to do that. That's why. No, yes, maybe? Again, this is weird. I'm not saying do this. I'm not saying don't ever do this. But you must, some of you guys, obviously a lot of you guys, should be like, yeah, why the shit do we do that? Anytime you have that, ask me. If I can't explain it, I must go find another job. I have to learn how to work with horses or something. I don't know. Shovel manure. I can do this. And some of you guys are like, yeah, it's the same thing you do every day. No, stop. But you guys, I really want you to understand, this is a way to investigate things. I use other processes that I understand to figure out something I don't. So I know how to rewrite this, and I know I want a 1 down here. That's the best number. So I make a 1 jump, and then I go, oh shit, there's a shortcut. Screw that shit. I'm just going to multiply by, because I'm always going to, what I multiply by the bottom, make it 1, the reciprocal. Oh, so I'm just going to make this multiply by the reciprocal. I know it's going to work. So now I make that a process. And then teachers forget why it works. And then students just accept it, or they finally ask the question, and teachers are like, because I said so. No, next chapter. Yeah, screw that shit. Right? Okay. Maybe. So the bottom line there, I'm sure somebody out there is like, why is he making this so difficult? This is why it works. If I just wanted to show you what to do, I would just say, okay, if you see this, then you make it 4/7 times 5/2, and then you do it. I mean, that's what you do. This is why you're allowed to do it, right? I'm not saying do this shit. I'm just, go ahead and do this. Understand why it works. I like it. So this whole semester, dear God,